All right, so here we have the final build for this quarter of the Quartz engine here. As you can see from the big old sprawling class diagram that we have here, it's not a particularly small system. So I'll just give a basic rundown of the flow first, and then I'll get into more details on the specific systems. So obviously the Quartz class here is the main class. It's the one that implements engine and gets the um, update draw calls from the game loop and sends them through to the various systems. So the Quartz file right here starts off with initialization, where the user through the game initialize file will be able to set the size, base color, name of the windows, those basic things. It also loads a set of default assets, things that are used by the system regardless of what the player does. So the visualizer has the bounding sphere, sprites need the sprite model, and the associated shaders of those are in there, as well as the texture shader. Um, Moving on from that, the load content is also done through player files. Go to definition here. So the player is able to add models, textures, images through the load resources folder or file. Those resources can then be used to create game objects. Here's the asset manager system here. Um, the asset manager is the main one that the user um, deals with. The managers underneath are the ones that actually hold the specific instances of models, shaders, textures, images. So with those, the user can define any number of game objects and their associated attributes. Those attributes being managed by the various scene sublevel managers here. Um, Scenes are the main workhorse of the game engine. Scenes will allow the user to hold a collection of game objects, define the interactions between them, and switch from one view of a certain collection of game objects to another. That's all managed by the scene manager here and routed through command systems here. As you can see, there's a couple different versions of command systems. We have registration and deregistration commands. Those are the main ones that get passed through the system by game objects, registering and deregistering themselves from various managers for various callbacks. There are the render commands that are used by the visualizer so that the visualizer spheres are drawn at the correct time. You can call it anywhere in code and it'll show up as intended. Set scene command is used by the scene manager level for switching scenes. Whenever a set scene command comes into the stack, then the scene switching mechanism will get put into place. And then obviously we have the collision-based command system that I'm going to talk about a little bit later when I get into the system itself. So first of all, we're going to talk about the asset and time managers. So the main asset manager here is the one that the user interacts with in the load resources method. It's got direct calls for adding shaders, models, textures, either by a file directly or by a model that's already associated. So for example, in our basic demo, the house will load 4 textures just from the single model. We also have the various gets here. So this is the one that the player will use when creating a game object to define what model, what shader, what texture that game object is going to use. Also have a time manager singleton here. Game time can return the time per frame, the delta time, as well as the time in seconds in general. And obviously that is helped along by uh, the freeze time, hack that you gave us. That's in and working correctly. I can demonstrate that later. Um, the asset manager basically acts as an umbrella for the various other managers. So if we, for example, look into the get image, it's going to check through to the image manager. The asset manager also goes through and deletes all of the managers on shutdown. So during the Quartz unload content, the asset manager here is being cleared out, which clears out all of the other asset managers below it. So moving on here to the scene and scene manager class. So the scene manager is in charge of scene switching and deals with things that aren't specific to a single scene. So registering a game object dynamically, not in the initialize function of a scene, is the property of the scene manager. Getting the current camera, something that's going to happen no matter what the scene is specifically, done through the scene manager. Um, so another thing that this adds, or this helps out with, is the setting the first scene. So basically, what it does here is it creates a essentially a null object that makes it much easier for the user to create the actual first scene. In the load resources folder, the user is going to, whichever scene they decide to use, is going to be set as the next scene. So there's no difference between setting a first scene and setting a next scene from the user side. So the scene manager deals with allowing access to the current scene so that objects can safely route through without having to worry about whether or not a scene is specific. A specific scene is the one they want. As for the scene itself, so the scene itself primarily is a collection of managers, and each of those managers here deal with game objects specifically. This scene also acts as a route through for the game objects to register themselves to those managers through the command runner here. Um, when an object is attempted to register, it will call the scene to say, for example, update register. Update register will push a command onto the stack at the top of the frame. I can show you here the scene update. At the top of the frame, all the commands are run through. Things are registered to their various managers before anything is processed. Then the processes start clicking through, um, and everything is done as according to the managers there. So callbacks are also routed through the scene level managers there. So the first thing that we can do is take a look at how the update and draw systems work. And I do have a demo ready for this, if I can pull it up here. So we're going to do the update draw scene, which is a fairly basic scene. There's going to be a couple 3D objects and a couple sprites up on the screen. One of them obviously the alien there moving around. So if we go into the code here, you can see that the scene is fairly simple. Just got the HUD and the two 3D objects here. And those are defined down in here. So for example, the HUD creates Quartz sprites. These are the wrappers that I created for the sprites. Adds them in, registers them for update, and registers the game object holder, not the sprites themselves. Registers for update callbacks and draw callbacks, and then obviously things are done through that system. So if we go back out here to the update manager, we should be able to see what's going on. Update manager is pretty simple. As it routes through the scene command system, uh, at the top of the frame, objects are added to this list of objects, and then when called by the scene, the update manager goes through and calls their callbacks here. 2D or the draw system is essentially the same thing. The only difference is that it's split between 2D and 3D objects. So it will call back as necessary there. And the scene itself deals with those in a different way. So update draw 3D and draw 2D calls are all separated out in the, I believe it's the Quartz file. Um, the, yes, okay. So the scene manager routes, the Quartz system itself routes through the scene manager to call the draws at the appropriate time. The first, all the 3D models are drawn, then the visualizer processes its sphere drawings, then the 2D UI sprites are drawn. And that ensures that we have no issues with the UI model blocking faces of any of our objects and causing transparency issues. The next subsystem I can point out here is, actually, why don't we switch to something a little more manageable? Go to the scene diagram here. I can show you a little bit more closely what the various managers do. So we've got the update manager taken care of, routes the update callback back to the registered updatables, image and model draw manager sending 2D and 3D callbacks as necessary. So here we've got the keyboard input manager and the single key managers. So the keyboard input manager is a collection of single key managers. The objects, whatever key responders we have, are registered through the scene level command system to the keyboard input manager. So when an object is registered for either pressed or released, the keyboard input manager checks to see if the single key manager has already been created. If it has, then it adds a responder to that single key manager. If it hasn't, it creates the single key manager and then adds a responder. For the single key manager's part, it is a collection of the registered key responder game objects. So it's just a simple list of both of those. Then the single key manager monitors whatever key it's been assigned to. So whichever is created here. When it, during its update, detects a difference between the previous key state and the current key state, it will then send the appropriate callback through to whichever side it needs to. If the key's been pressed, it sends a key pressed callback to all the pressed responders, same for the released responders. For the All right, so then we can move on to the next subsystem. We've got the alarmables section here. So alarmables are a little bit more complicated. In order to have 5 different alarm callbacks, we have a little bit more complicated system here. So when the user wants to register an alarm, they decide which number they want to create. Goes in here. It creates uh, an uh, an alarm marker in the alarmable class. That alarm marker is then pushed through to the scene manager. Give me 1 second here. Passed into the scene manager. The command relating to those pushes the alarm marker. Oh, I guess I didn't mention this before. So I did get the um, command factory to work. So we do have commands recycling themselves through. Um, the only real problem with that is that no, that's not the one. That on the return function, yeah. So that's right. Okay. So the public static return command function has a switch on which ID the command is and then routes it through the correct private call for that command, obviously having to cast it down from a command to the correct pointer. But for the alarmables, so the alarmable manager, if I can skip to that real quick here, alarm manager here. So the alarm manager has a timeline map of the time when an alarm is supposed to go off in total seconds that the game has been played, and then has an alarm marker which holds its own callback to the specific object that needs to know when that alarm goes off. So that means that during the alarm manager's update, which is the process alarms called through the scene here, it only has to check for the closest to ready alarm. It doesn't have to check through the entire collection of registered alarms. These here allow alarms to be set for the same exact frame, and that will safely check through all of them. It also deletes by iterator, not specifically by key. So adding alarms is safe, and I can demonstrate that right here with the I can demonstrate that here with the advanced features demo. So we have a reactive wireframe box here that registers itself for the alarm. Color switch time is, I believe, 1.25 seconds. When that alarm goes off, it switches the color between blue and green, and then resets itself, resets the alarm back to alarm 0. So if I switch on over to the load resources and load that scene up, you can see that the box does indeed switch back and forth with no issues. So the next up, and probably the most complicated system on the list so far, is the collision system here. So the collision manager holds the collection of registered collision commands. Those are the different tests that are needed to be done between pairwise two different types of collidables or the collidables against themselves, and processes them every update as directed by the scene. The collision commands are created by a user level scene call. that define the pairing or the single group of objects that need to be checked against themselves. So if we go ahead and check here, I know you wanted a specific note of making sure that the collisions with self and with others are working properly. So I'll test this in game, but as you can see from right here, doesn't test collision with itself. And just like with the collision pair, it will trigger the exact, you know, the exact two that are being collided with and none of the other ones, even on the self command. Um, Then also we have the collidable groups. That is a singleton that is used or that is registered to by game objects defined as collidable. So they will uh, the collidable group is a bucket of templated, C objects that allows for collision between user-defined types, not specifically collidables only, so that the user can be more specific about what's colliding with what. The collidable group, like I said, is a singleton that holds a collection of those objects and allows the collision test to get those collections of objects and test through them all. The collidable groups also are deleted by the collision manager when it closes down. So every time a new collision group is added, it gives the collision manager a command that's ready to process through that will essentially call the delete and cleanup for the collidable group here. Deletes the instance to null pointer. And that is managed by the collision manager, which obviously is at the scene level, so is shut down when the scene is shut down, ensuring that there's no issues there. So all that done, I can show you, I can go through the different demos I have set up to be sure that everything works. So collision demo here, we have several objects. If I can, let's update draw. We want the collision demo. So we have a player ship, deactivated ship of the same type that will allow us to check self collisions, and a target box that will allow us to check different collisions. So here we've got moving ship against target box, moving ship against self. And then if we load up that scene here, we'll see we've got the player's movable ship here that you can toddle over here, will collide with the box correctly. It looks like it's a little off. That's just because of the angle. I didn't add in the God cam for this demo specifically. But if we zoom on over here to the other frigates, the other ships, we'll see that they do collide, and they collide with only the proper two. So some more features that aren't by definition part of the engine, things like creating creating a factory for different classes. I have also put in and tested out. That's in the full demo scene here. So if we load it up, we've got a recycling bunch of commands here, or bunch of alarms going off here. We can see that multiple ones are going off without any issue there. If we switch on over to this one, we can see that we've got objects popping in and out of existence. They are being recycled through the factory that I've created. You can see that the collisions are also working in this version, and we even have a little bit of testing of the sprites going on here. So, other than just those demos, I also have the Doxygen uh, documentation set up. So we've got the welcome page here with linked code examples. We also have the modules here, which are kind of more of a smoother introduction to the engine. Describes the basic structure of the engine, where to set up the basic attributes of the game window, where to load in your various assets, and then from there talks about the basics of game objects, the basics of scenes, shows you a little bit of how to set that up, shows you a little bit of the setup of game objects and the appropriate methods for those two to be registered into the game systems. A little bit of code here to kind of show what needs to be done, and a little bit of a description of each of the various basic events that a game object can call. In the advanced features, we have more of that. So we've got collision input response alarms, those kind of things. And the demos that I showed you are also documented in here. We've got the full source code for the update draw demo, the advanced features demo, and the collision demo here, with links to each of the objects specifically: HUD, textured ship, update draw scene, box, everything right in there. So I think that about covers it for this sprint video. Thanks very much.